Right, in this video, we're going to talk about section 2.3 dealing with linear functions and slope. So in this section, we're going to be calculating the line slope. Then we'll write the point slope form of the equation of a line. And then we'll write and graph the slope-intercept form of the equation of a line. And then we'll graph horizontal or vertical lines. And then we'll recognize and use the general form of a line's equation and use intercepts to graph the general form of a line's equation. So this section does have a lot that we're going to cover in this video. Okay. So first, let's talk about the slope of a line. The slope is a measure of a line's steepness. Okay, so think of this. Hills have what we call slope because you're going up a hill or you're going to be going down a hill. They do have slope. Okay. Also, some streets where they have overpasses, those streets can also have slope. And also a ramp where handicapped people use to gain access to buildings, that also has a slope. Okay. Now the slope compares the vertical change, which is the rise, to the horizontal change, which is the run. So in this case, if I had something like this, okay, what goes up and down, we call that the rise. And what goes across, we call that the run. So it's going to be a ratio of the vertical change to the horizontal change. And to calculate the slope of a line, we use a ratio that compares the change in y, which is the rise, to the corresponding change in x, which is going to be the run. And here we use this definition of a slope. Now, let's say we have 2 points, x1, y1, and x2, y2. The slope of a line through those 2 distinct points is going to be this. Here we use the lowercase m to denote the slope, and that's going to be equal to the change in your y coordinates divided by the corresponding change in your x coordinates, which is also rise divided by run. And if we use these ordered pairs directly, it will be y2 minus y1 divided by x2 minus x1. And the restriction here is where x2 minus x1, the difference in your corresponding x coordinates cannot be equal to 0. So now let's look at a couple of examples of this. Let's say we want to find the slope of the line passing through each pair of points. Okay, and that's -3, 4, and -4, -2. Okay, so here's what we're going to do here. That first ordered pair, -3, -4, I'm going to let x1 be -3 and y1 be -4. And then for -4, -2, I'm going to let x2 be -4 and y2 be -2. So now in this case, our slope formula that we will use is this. M is equal to y2 minus y1 divided by x2 minus x1. Okay. So we just substitute those values into that slope formula, and then we can find the slope. All right. In this case here, y2 is -2 minus y1, which is 4. Now keep in mind, in the numerator and the denominator, we're always going to subtract our corresponding y's and our corresponding x's. So in this case here, x2 is -4 minus x1, that's -3. Okay. And now we can just subtract the numerator and subtract the denominator. -2 minus 4 is like -2 plus -4, that's -6, over -4 minus a -3. That's the same as saying -4 plus 3. That would be -1. And -6 divided by -1 is 6. So the slope of that line passing through those 2 points is 6. All right, here's another one, part B. Here we got 4, -2, and -1, 5. And here I want to find the slope of that line passing through those 2 points. So again, take the first ordered pair of 4, -2 and let x1 be 4 and y1 be -2. And then -1, 5, the other ordered pair, I'll let x2 be -1 and y2 be 5. So in this case, our slope formula is still y2 minus y1 divided by x2 minus x1. So here, y2 minus y1, that's going to be 5 minus -2. All divided by x2 minus x1, that's -1 minus 4. And then we go ahead and simplify this. -5 minus 2 minus -2. -5 minus -2, that's like -5 plus, I'm getting negative up. 5 minus -2 is the same as 5 plus 2. That would be 7. And then -1 minus 4, that'd be like -1 plus -4. That would be -5. Now we're going to leave this as an improper fraction. So in this case here, our slope would be -7/5. And let me inform you, in the homework, they're going to want the negative typed in first and then use your fraction icon to type in 7/5. So it'd be -7/5. Okay. All right, next we're going to look at the 4 possibilities for a line's slope. Okay. So here your slopes could be either positive or negative or 0 or undefined. Now let's look at positive slope. In example 1a, I just did an example where the slope was a +6. Here that has a positive slope because your slope is greater than 0. And what happens here is if you were to graph the line with that slope and those given points, you'll see that the line rises from left to right. And then negative slope is somewhat like example 1b. I got -7/5. Here you have a negative slope, meaning that the line would fall from left to right if I was to plot those 2 points on a coordinate plane. And then next would be a 0 slope. If your slope is 0, that means that the line is going to be horizontal. And a couple of an example of that would be something like the ordered pairs 7, 8, and let's say -1, 8. And here I want to find the slope of that line going through those 2 points. Well, the slope would be m, and that's equal to, here would be y2 minus y1. That's 8 minus 8. Divided by x2 minus x1, -1 minus 7. And when I simplify that, 8 minus 8 is 0. -1 minus 7 would end up being -8. 0 divided by -8 is 0. So if I was to plot these 2 ordered pairs on a coordinate plane, I would get a horizontal line. And in a horizontal line, the slope is 0. And then the undefined slope is where the line is vertical. Okay, so here the slope there is undefined. So for 2 points like, let's say, 6, 8, and 6, -3. In this case here, if we were to use that slope formula, this will be y2 minus y1, -3 minus 8, divided by x2 minus x1, 6 minus 6. And if I do -3 minus 8, that's -11 over 6 minus 6 is 0. Notice I have a 0 in the denominator. So that tells you that your slope for the line passing through those 2 points would be undefined. So that means we have an undefined slope. Okay. All right, next we'll look at the point slope form of the equation of a line. And here it is. The point slope form of the equation of a non-vertical line with a slope of m that passes through the point x1, y1 is this: y minus y1 equals m times the quantity x minus x1. Okay. Now in a equation, you're going to always have a y and an x in it. The only thing you'll substitute is y1, x1, and m, which is your slope. Okay, so now let's look at this example, example 2, where we're going to write the point slope form of the equation of a line with slope of 6 that passes through the point 2, -5, and then solve the equation for y. So here we got a slope of 6. That's what m is. M is represented by the slope as 6. And the point we're dealing with is 2, -5. Okay. So in this case, x1 would be 2 and y1 would be -5. So here we got a point and a slope, so we can directly use that point slope form. And that's y minus y1, and that's equal to m times the quantity x minus x1. And then we substitute the m, the x1, and the y1 in that point slope form. So in this case, we're going to have y is y minus y1 is going to be -5. That's equal to m, the slope, which is 6, times x minus x1. That's going to be 2. All right. Now, if I rewrite that y minus -5, that's going to be y plus 5 equals 6 times the quantity x minus 2. So in this case here, we call this point slope form. Now keep in mind, in the homework, they're going to ask for 2 things in my math lab. That is the point slope form, which is this. And the other one, you're going to solve the equation for y. And to do that, we'll just finish the rest of this. So I'm going to bring down the y plus 5. That's equal to, distribute the 6 over the x minus 2. You'll get 6x minus 12. That's 6 times x is 6x. And then 6 times the minus 2 will give you minus 12. And then you're going to solve this equation for y. We want to get y by itself, we're adding 5. So that means we need to subtract 5 on both sides. So that means y is equal to 6x. -12 minus 5 will be minus 17. That's your equation solved for y. Y equals 6x minus 17. This represents the equation of the line with a slope of 6 and passing through the point 2, -5. Okay. Now, in this example, you were given a point and a slope. This next example, which is example 3, here you're given 2 points. And we want to write the point slope form of the equation of the line passing through -2, -1, and -1, -6. And then you're going to solve the equation for y. Okay, so we got -2, -1, and -1, -6. And here I have to first find the slope, because in order for me to use the point slope form, I need to know what that slope is. Well, we already know how to find the slope of a line passing through 2 points, and that's using the slope formula. M is equal to y2 minus y1, all divided by x2 minus x1. Okay, so here in this case, I'm letting -2 be x1 and -1 be y1. And in this ordered pair, I'll let -1 be x2 and -6 be y2. So let's substitute. Y2 minus y1, that's -6 minus -1, divided by x2 minus x1. That's -1 minus -2. All right, if I simplify this, -6 minus a -1 is like -6 plus 1, which is -5. And then -1 minus a -2 would be like -1 plus 2. That would be 1. So I got -5 over 1, or -5 divided by 1 will be -5. So the slope is -5. And now I'm going to use that slope of -5, and let me just write this over here. Use the slope of -5. And also I can use either one of these 2 points, either -2, -1, or -1, -6. I'm going to use the first point, -2, -1. Really doesn't matter which one you use. And if I use that, then that means that -2 will be x1 and -1 will be y1. And of course, my point slope form is this: y minus y1 is equal to m, which is the slope, times x minus x1. And then we substitute the m, the x1, and the y1 in this equation. So it'll be y minus y1 is -1, equals to the slope, which is -5, times x minus x1, which is -2. Okay. Now, if I simplify this a bit, that y minus -1, I can write that as y plus 1 equals to -5 times, I'm going to write x minus -2 as x plus 2. This is your equation in point slope form. Again, in the homework, they will ask for 2 things: the point slope form and the equation solved for y. So this is point slope form. And for the equation to be solved in y, we'll just finish this out. So I'm going to bring down the y plus 1, and that's equal to, distribute the -5 over the x plus 2. -5 times x is -5x. And -5 times the plus 2 would be -10. So that y plus 1 is equal to -5x minus 10. And to solve for y, I'm adding 1, so I need to subtract 1 on both sides. So that means y is equal to -5x minus 11. So that's your equation solved for y. Okay. Now, in those two examples that I did, examples 2 and 3, we solved the equation for y. Well, that has a special name. When that equation is solved for y in terms of x, we have what they call the slope-intercept form of the equation of the line. And it says here that the slope-intercept form of the equation of a non-vertical line with slope m and y-intercept b is this: y equals mx plus b. And when it's in slope-intercept form, we can identify the m, which is your slope, and the b, which is your y-intercept. The slope is always going to be the coefficient of your x term. Your b is the y-intercept. That's going to be the number added to or subtracted from that linear term. Okay, so in the equation of a linear function, the x coefficient is the line slope and the constant term is the y-intercept. So a couple of examples are like this: y equals 2x minus 4. So here, the 2 in front of the x, that is your slope. This minus 4 represents your y-intercept. And also can be written as a function like f of x is equal to 1/2 x plus 2, where the 1/2 here is your slope, that's the coefficient of x, and the plus 2, that's your y-intercept. Okay. Now let's talk about how to graph an equation that's written in slope-intercept form, y equal mx plus b, using the slope and the y-intercept. Okay. And here's the procedure for doing that. Number one, you want to plot the point containing the y-intercept on the y-axis. That would be your first step. And then number two, obtain a second point using the slope, which is your m. And you're going to use the concept of rise over run, starting at the point containing the y-intercept. Okay. And then finally, you'll draw the line going through those 2 points. So like in example 4, let's say I want to graph this linear function. F of x is equal to 3/5 x plus 1. Okay. So the first thing you need to do here is identify the slope and the y-intercept, because f of x is already by itself. The slope is the coefficient of your x term. That's 3/5. And the y-intercept is 1. But if you recall, the y-intercept is always an ordered pair when x is 0. So actually your y-intercept is going to be the ordered pair 0, 1. And the y-intercept is going to be the point where the graph of that line will be crossing the y-axis. Okay, so now let's use this to do our graph. So the first thing we do here is plot the y-intercept, which is actually the ordered pair 0, 1. So we stay at 0, but go up 1 and draw that point. That's your y-intercept. Now the slope is 3/5. So here we're going to use the concept of rise over run. The numerator is going to be the rise, and the denominator is going to be the run. Now keep in mind, if your slope is a whole number, you need to put that whole number over 1 to identify the rise and the run. Okay. Now notice that the 3 is positive and the 5 is also positive. The rise tells me how many places I need to go up or down from the y-intercept. And then the run is going to tell me how many places I need to go either to the left or to the right. And it's usually dependent upon the sign. So in this case here, the rise is 3 and it's a positive 3. So starting at the y-intercept of 1, I will rise up 1, 2, 3 places. So here I'm going up 3. The run is a positive 5, so I'm going to run to the right 1, 2, 3, 4, 5, and draw that point. So that's where that second point will be. And if you want to do it again here, you could do this. Use that point that you came up with, go up 1, 2, 3, and to the right 1, 2, 3, 4, 5. So another point will be right there. But in reality, you only need 2 points to draw a line. The third point can be used as a check. So what I'm going to do here is use my straight edge and draw the line through those 3 points. Okay. Now this represents the graph of the line. F of x is equal to 3/5 x plus 1. F of x is equal to 3/5 x plus 1. Okay, now I do have another example that I want to share with you that deals with a negative slope, like this one right here. In this example, I got f of x is equal to negative 4x minus 3. And here I want to graph that. Now I had to identify the slope and the y-intercept. The slope is the number that is in front of the x, which is in this case, negative 4. The y-intercept is at negative 3. And notice for negative 4, I had to write that as negative 4 over 1, because I need to identify the rise over the run. And my y-intercept, of course, will be 0, negative 3. So here I plotted 0, negative 3 on the coordinate plane, which is down here. All right. Now my rise is going to be negative 4. The run is going to be positive 1. Keep in mind, if your slope is a whole number, you need to put that number over 1 because you want to identify the rise over run. So starting from the y-intercept, which is negative 3, my rise is negative 4, so I need to go down 4 places from that y-intercept and run to the right 1. Okay. Now, another way I could have did this was made the 4 positive and the 1 negative. If I did that, then from this y-intercept, I would have gone up 4 and to the left 1, and then connect the points to draw the line. So here, this will be the graph of the equation of f of x is equal to negative 4x minus 3. Okay. Next, we'll look at equations of horizontal and vertical lines. And that's this. A horizontal line is given by an equation in the form y equals 0, where b is the y-intercept. Okay, so here we have a horizontal line going straight through the y-axis at the value of b. And that y-intercept is, of course, the ordered pair 0, b. And equations expressed as f of x equal to b are considered to be constant functions. Guess what they are? Constant functions. All right, so let's say we have this. We want to graph y is equal to 3 in the rectangular coordinate system. Y is equal to 3. That's a constant linear equation. Now, the way that I can do this is create an XY table. And I can pick any X value that I want. Like in this case, I can pick negative 1, and then 2, and 6. But regardless of what X is, Y is equal to 3. That means the Y coordinate for each one of these corresponding X coordinates has to be equal to 3. Has to be. And now let's plot this, of those ordered pairs on the coordinate plane. So let's do -1, 3 will be to the left 1 and up 3. 2, 3 will be to the right 2 and up 3. And 6, 3 will be to the right 6 and up 3. Now you can see those 3 points form a horizontal line. So here, I'll just draw that horizontal line through those 3 points, and it does cross the y-axis at 3. And that's the graph of the horizontal line. Y is equal to 3. Okay, now we'll look at what a vertical line is. A vertical line. All right, a vertical line is given by an equation in the form of x is equal to a, where a is equal to the x-intercept. So here's the vertical line that you see on the right side in blue. Cross the x-axis at a point called A, and that ordered pair will be A0, so your x-intercept will be A. Okay? And since it's a vertical line, no vertical line is a linear function. And that makes sense because if you were to do the vertical line test, this vertical line would fail because you're going to have the same x values, but different y values. So here, it would not be a linear function. Okay. Now let's look at an example of a vertical line that we're going to graph, like x is equal to -3. And the same linear equation, because it's not a function, by the way. So if I draw a table of values, let's say we know x has to be -3, regardless, because that's what x is equal to, -3. Y could be whatever I want to, like, let's say -4, 2, and 5. And now we'll plot those ordered pairs on the coordinate plane, like -3, -4 would be to the left 3 and down 4. Sorry about that. And then -3, 2 would be to the left 3 and up 2. And then finally, -3, 5 would be to the left 3 and up 5. So you can see here those 3 points form a vertical line. And that's the graph of the vertical line. X is equal to 3. Okay. So be familiar with how to graph a horizontal line. If you have y is equal to some constant, it's automatically a horizontal line. If x is equal to some constant, then that means you have a vertical line. Okay? Now let's look at the general form of the equation of a line. All right, every line has an equation that can be written in the general form, which is this: ax plus by plus c equal to 0. And this is where a, b, and c are real numbers, and a and b are not both 0. Okay. Now, to identify a slope and a y-intercept of an equation that's written in general form, the first thing you have to do there is solve the equation for y. In other words, you'll have to move terms over to the opposite side to get y by itself. Once you do that, it will be written in slope-intercept form. That way you can identify the slope and the y-intercept. And that will give you the information you need to graph that linear equation. Like in this example. Now here the graph is going to be on the next page. And that's this. Here we want to find the slope and the y-intercept of the line whose equation is 3x plus 6y minus 12 equal to 0. Then use the y-intercept and the slope to graph the equation. Okay, so I'm going to do this on the next page here because here is the graph. Now I'm going to write down that 3x minus plus 6y minus 12 equal to 0. And I need to solve this equation for y. That means I need to move the 3x and the minus 12 over to the other side and get rid of the 6x in front. Let's get rid of the 3x and the minus 12. It's a positive 3x. I need to subtract 3x on both sides. And I'm also going to do this. Since I have the minus 12, I might as well go ahead and add 12 to both sides. That means that 6y is equal to negative 3x plus 12. And then to get y by itself, I'm multiplying it by 6. Let's multiply each and every term in this equation by 6. So that means y is equal to, here I'm going to have negative 3 over 6. If I reduce negative 3 over 6, this will be negative 1/2. So I got negative 1/2 x, and then plus 12 divided by 6 is 2. So this is my equation in slope-intercept form. Y equals negative 1/2 x plus 2. Now, since it's in slope-intercept form, I can go ahead and identify the slope and the y-intercept. The slope is the coefficient of x, that's negative 1/2. The b, which is your y-intercept, that's going to be 2. And actually, the ordered pair for the y-intercept is 0, 2. So now I can go ahead and do the graph of this line. Let's see, plot the y-intercept first. That's 0, 2. Stay at 0, but go up 2. That's your y-intercept. Now, my slope is a negative 1/2. This is what I'm going to do here. I'm going to make the 1 negative and the 2 positive. Now, if you want to, you can make that 1 positive or the 2 negative. Okay? So that means the rise is negative 1 and the run is 2. So in this case here, starting from the y-intercept of 2, my rise is negative 1, so I need to go down 1 place from the y-intercept. The run is a positive 2, so I'm going to run to the right 2 and draw that point. And if I want to get another point, I can use this right here, this point that I came up with, go down 1 and to the right 2. Or I could have did this, took that y-intercept that I came up with, make the 1 positive and the 2 negative, go up 1 and to the left 2 to get the other point. All right, but these are enough points that I need to draw the graph of that linear equation, which is in this case 3x plus 6y minus 12 equal to 0. Okay. All right, finally, we'll talk about how to use intercepts to graph ax plus by plus c is equal to 0 when it's written in general form. We can use x-intercepts and y-intercepts as well. If you recall, back in chapter 1, we did talk about, well, in case you don't know, the x-intercept is the point where the graph crosses the x-axis. And the y-intercept is the point where the graph crosses the y-axis. Okay. And once again, let me share the screen with you. Okay, here it is. That's the definition of the x-intercept and the y-intercept. The x-intercept is always the point where the line crosses the x-axis. The y-intercept is just the point where the line crosses the y-axis. Okay. And here I do have the procedure for finding the x-intercept and the y-intercept and plotting both points and drawing the line. Okay. So here it is. I also have it here. First of all, you find the x-intercept by letting y equal 0 and solve for x. And then you'll plot the x-intercept on the x-axis, because that's the point where the graph will be crossing the x-axis. And then number 2, you're going to find the y-intercept by letting x equal 0 and solve for y. Okay, so you'll plot the y-intercept on the y-axis, because that will be the point where the graph crosses the y-axis. And then finally, you'll draw a line through the 2 points. Okay, now, so in this example, I got 3x minus 2y minus 6 equal to 0. And I want to graph using both the x-intercept and the y-intercept. Okay, so in this case here, we'll first find the x-intercept. So here we let let y equal 0. You're letting y equal 0. And then you're going to solve the x. So in this equation, I'm going to substitute the y with 0. So this will be 3x minus 2 times y will be 0 minus 6 equal to 0. Now, when I do 2 times 0, that's going to give me 0 here. So I'll be left with 3x minus 6 equal to 0. And then we're going to solve the equation for x. So if I add 6 to both sides, that means 3x is equal to 6. And then divide both sides by 3. That would mean x is equal to 2. So x equals 2. That's going to be where the line would be crossing the x-axis. And the ordered pair for that x-intercept would be 2, 0. So that's my x-intercept. And now for the y-intercept. Here, we let x equal 0 and solve for y. So in this equation, 3x minus 2y minus 6 is equal to 0. We just replace the x with 0. So it'll be 3 times 0 minus 2y minus 6 is equal to 0. Well, 3 times 0 gives me 0. So you're only going to be left with negative 2y minus 6 equal to 0. And then to get the negative 2y by itself, we're going to add 6 to both sides. So that means negative 2y equals 6. Divide both sides by negative 2 in this equation. You'll get y is equal to negative 3. So that line is going to be crossing the y-axis at negative 3. And the ordered pair for your y-intercept would be 0, negative 3. And now we can go ahead and plot the x-intercept and the y-intercept on the coordinate plane and come up with our graph. Use green. My x-intercept is the ordered pair 2, 0. So I'm going to go to the right 2 and draw its point. My y-intercept is the ordered pair 0, -3. So I stay at 0, but go down 1, 2, and 3 and draw that point. All right. Connect those 2 points. And this will be the graph of the line 3x minus 2y minus 6 equal to 0. All right. And on the last page is just a summary of all the things that we talked about in this section and in this video. So for your equations of lines, be familiar with those. The point slope form, which is y minus y1 is equal to the slope m times the quantity x minus x1. That's when you're given a point and a slope. Or if you're given 2 points, you have to first find the slope using m is equal to y2 minus y1 divided by x2 minus x1, and then use the slope in either one of those 2 points in your point slope form. And then we talked about slope-intercept form, y equal mx plus b. The m, the coefficient of x, is your slope. The b, the number added to or subtracted from, that's your y-intercept. And the horizontal line is always y equal to some constant b. The vertical line is always going to be x is equal to some constant a. And of course, the general form of the equation of any line is always going to be ax plus by plus c equal to 0. That means the x, the y, and the constant terms are on one side, and you have a 0 on the other side of the equation. So those are the 5 equations that you should be familiar with by the end of this lesson. So this does conclude this video on section 2.3 dealing with linear functions and slope. So do feel free to email me if you have any questions about any of the examples presented in this video or anything about the homework that's in my math lab.